My name is Israel, as Danny said. So I work as a data scientist for BBVA Data Analytics. It's a small company focused on data science that belongs to BBVA, the bank. So, but we are actually doing a lot of products, just as we were integrated with the bank. Previously to that, in an earlier life, I was doing research in academia, working on analyzing open source from an empirical software engineering point of view. And what I'm going to show here today is how what I learned doing this research on how open source is done can actually make data science better. So when I was hired, I was hired for a very specific problem at the BBVA, which was making it easier to promote data science products to production, which is always a painful process. So data scientists are a very specific kind of people. I'm a data scientist. Is anyone else here a data scientist too? So do you call yourself a data scientist? Don't be shy, no problem. Danny, okay. Okay. So if you ask a data scientist, are you a programmer, are you a developer, they will say no, but they keep writing software every day. Like that's what they do all day. Okay. So we know that making software is complex. So software engineering is about that. So software engineering as a discipline was born because making software was more complex than what people initially thought. And open source is a very good example of software engineering. So if you take classics software engineering textbooks and try to apply what they say to the way open source is done, so they will predict that it should be a total failure, because open source is done by people, distributed across the world. Most of the times they have not even talked to each other in person, like in physically in front of the other part ever at all. They don't write requirements. They start writing code, and they prefer to write code rather than to write documentation and so on. Okay, but in spite of all this, so we see, and saying this today is really obvious, but open source is a huge success. So 3 billion mobile phones in the world are using Android, and they are running a lot of open source. Even Macs are using open source. So the kernel Darwin is open source. So there is open source everywhere, and it really in billions of devices nowadays. So open source has been there, has done that. So the open source has been delivering high quality software for decades now. And from the data science point of view, working as a data scientist, I will talk about this more later. Working in open source and talking too much, and industrialization is a key, crucial aspect, because your ability to deliver is the value that you will have for any company. So this is really a crucial aspect. And data science projects are even more complex than a normal software project because of many different issues. Okay, so really interesting topic. When I talked to my wife about all this stuff, when I told her, like, I'm joining a bank, and so okay, so what are you gonna do there? And I started to explain. It's really okay. Yeah, sounds fascinating. No, really, is it really that important? Have ever people died because we were not doing things properly? Actually, they have. Yes. So we have invented killing machines. No, I work in artificial intelligence, and you know the singularity and all that. Elon Musk, Stephen Hawking warning about the dangers of artificial intelligence. We are raising the machine, and it will enslave us in the future and so on. But we didn't create the first killing machine by doing sophisticated artificial intelligence. We did it by doing sloppy software. Okay. So this machine, the Therac-25, it was a radiotherapy system in Canada in the 80s, and it killed 4 people. It really injured very severely two other people, and it did it because the software was not properly done. Yeah, yeah. So the links that I included in this slide, so you have more details about this system, and there was a serious, rigorous process analyzing what went wrong and so on. And what they found is that the code was written by a person but never reviewed by another person, no code reviews at all. There was no unitary testing at all, so code was written and that's it, and put into the system. There was a lot of duplication of code because it was a huge system with lots of devices, drivers, and so on. There was a lot of copy paste with no review and no test. And the problems that killed these people were really corner cases that were very difficult to reproduce in and to rerun. So what? Okay, so what is the relationship of this with data science? So in data science, the kind of people that you find are scientists, people coming from academia, like me, but I was doing research on software engineering, so I had an advantage. But you find a lot of people coming from mathematics, physics, and many backgrounds other than software engineering, biologists, all kinds of backgrounds. They are very good at science, but they don't have so much experience at engineering or software engineering. And also in data science, in order to keep the credibility and in order to be able to be sure that your results are okay, science works by reproducing, by repeating experiments. So that's the way science works. So people focus on that. So let's think, for instance, of notebooks. Notebooks are a extremely popular tool nowadays in data science, right? But they were not born as a tool for data science. They were actually intended to be a tool for scientists, to be able to reproduce work and to share experiments and so on. That's why they are so popular in data science, and they are very good at this. So if you want to share an experiment with another person, doing it with a notebook, it's an excellent tool for that, and for many other things. So for instance, for delivering a talk or teaching on an issue with a notebook, that's an excellent tool. So it's actually thought for that, and it does that job very well. But the engineering side, that doesn't do it so well. It's you cannot test it on the notebook. You cannot commit a notebook to a repository and have like a easy code review of a small bunches of code. So they are not thought for that. So in data science we have tools that are meant for science but not for engineering. And just to finish giving the full picture, the way data science things are normally structured in companies are more focused on the science side than on the engineering side. So have you ever seen this picture before? So this is from a famous paper from Spotify about how they organize their development teams. So this is in my not so short experience in industry in data science. I've been in 2 companies only, but in the 2 companies where I have been, so this is the way data science teams were structured. So you have these squads or teams that are small, that are autonomous. They control the product they work on, and they have different kinds of profiles: data scientists, data engineers, people from the business side, and they are all working together in small teams, very focused on one specific product. They have end-to-end ownership of that product, and that's really great because you avoid a lot of problems, a lot of communication problems between different departments in a company. However, focusing on that, you are neglecting other parts, like for instance, common practices. Because teams are autonomous, teams are also kind of separated, and communication, even though they work in the same physical space, doesn't work so well. So you have lack of common practices. Each team is doing stuff as they think it's better. So quality is inconsistent. You don't have the same quality standards in different verticals, in different teams. because you don't have the same practices and the same quality standards, promoting to production is a very painful process. So think that we work in a bank. A bank is, so putting things in production, the bank take it really extremely seriously. So all companies take very seriously this, but in a bank, you know, the purpose of a bank is not giving you another nice feature in your mobile app. So that's very good because it helps the business. But the main purpose of the bank is keeping your assets safe and available for when you need them, how you need them, and so on. Okay, and that cannot be put under any threat. So promoting something to production is really, really, really strict. If you have a lot of diversity across different products, promoting to production will be always very painful because it will be a totally new issue for the industrialization team. And this is really a big problem for data scientists. When you work as a data scientist in a company, your credibility is always at risk. So you come from an academic background with PhDs and sophisticated degrees, and you've been in dozens of countries and know people all around the world working on really advanced topics. And after running a query, you go and tell a guy that we have 10 million customers, or wherever. And the guy looks at you, is like, you're such a fool. It's like everyone knows here that we have 50 million customers. It's like, do you need a PhD to know that? Okay, so your credibility is at risk if you don't really take quality very seriously. And if you are not able to deliver to production, well, you are really in a very bad situation unless you try to fix it. And the other point is that it's because people are working in verticals in different things. Collaboration is not so easy. The purpose, the focus, the goal of each one of these teams is delivering their product. They are not paid to be collaborating. They don't have the incentives to collaborate because that's trying is like taking away time from their main goal. Okay, so tools that are meant for science and not for engineering, and organizations that are meant to be able to integrate data scientists into the business. These two things are making the industrialization of data science more difficult. So, how are we fixing this in the bank? So, how are we going to work to be able to overcome all these issues? Well, that's the purpose of the next slide. So, what we are doing is we have two main goals. The first goal is no defects on production. Zero post-release defects. And the second one is no waste. You don't repeat what someone else has done in the bank. You don't reinvent the wheel. You collaborate, you reuse. So how are we going to achieve these two goals? Well, with InnerSource. So more in detail. These are the 7 sins, the 7 commandments of the software projects that we have in data science. The first one is that you must be using version control, and this one is basic. But you will be surprised how many people are doing stuff and they are not even using version control. And let's not talk about continuous integration. So like automated testing, all that. So like that's really advanced for many things in many companies. For things that are not software engineering teams, people who are doing software, but they are not software engineering teams. The second one is that you don't write the code that is in the repository if someone else doesn't approve it. They have to review it and approve it. And you don't review like you were their mother. You review really without any kind of mercy. Okay. The third one is that you test. Unitary testing. You write a piece of code, you have to write the corresponding test. Otherwise, the work is not done. Fourth one is that you have to be able to deploy from the repository. If you are not able to produce a package that is deployable somewhere, somehow, then you are still missing some part. You are using an issue tracking system. Every time there is a new feature, you find a bug, you log that. Traceability. You know what's going on. Who fixed the what, and how, and when, and where, and who reviewed that, and who approved it. And the last part is that you agree on how you are gonna do stuff and coding guidelines mainly. Okay, so these are our 2 main goals, and this is our 7 commandments that we have to fulfill in any project that we are starting in our unit in the bank. So this is what we are doing. So this is a typical continuous integration process. So we have here the start of a work is always a pull request that is done with Git. So we are currently using Bitbucket. Someone else has to review that. Because of some issues that I'm not gonna enter into more detail here, we do all the continuous integration after merging the code the pull request. We cannot do all these other steps before doing the code review. So then you enter the continuous integration cycle, and you test, you analyze the quality, and you deploy. Okay. So this is the basic process that we are trying to enforce, and that's it. So we don't try to enforce more. So every team is autonomous on how they do this. They control their pipeline. They have end-to-end ownership from the start of the work. They define what they are working on, and they define how to test it, how to analyze it, how to deploy. So they define that, but they have to do that. Okay. And okay, so 2 more points. Is the repositories where we put the code are open to anyone in the bank. Any person in the bank can fork your repo, can read your code. So anyone can do a code share and try to find something. Anyone can go to your repositories and use your packages, and anyone can actually go and open an issue, request a feature, send you a pull request. It doesn't happen so often, but anyone at least has the tools to do that. Okay. So more in detail, what we are doing is this process. Okay. So I'm not going to enter into a lot of details now here. If you want to know more, we can cover this in the questions. It's the same process as the previous slide, but with a little bit more of detail. Just one important point. So here we have the evaluation of qualities in static analysis, and also some metrics about testing, coverage, and others. If this system is giving you no OK, you don't release. Okay, so that's what you are going to promote to production. You have to do it with a release, and the release has to achieve a minimum level of something. So that's the only difference. Everything else, it's totally under your control, under the control of each one of the teams. Okay. You may think it's like data scientists are not really happy that a guy is coming here to the company to tell them how to work. So imagine I've been in this company only for 6 months, and I was totally excited when they told me that my job was going to be to do this. It's like, okay, so I'm going the new guy in the company. I don't know much about finance, about the banks. I have people who are really smart, stubborn, with PhDs, with lots of experiences, and they know all these obscure things about the financial products and all that. And I'm gonna be the guy telling them, it's like, you are working in this way, that's wrong, now you have to work this way, okay? Really, yeah, it was a nice job. Actually, I rejected at first, and at second, at the third, at fourth, and then the 5th time I said, well, maybe I should do it. Okay, so how do we manage to convince people to do this? Well, truth is that people were already suffering all the issues I have mentioned before, so they were already convinced that they had to do this. And the second is that all this process that we put here is producing all kinds of data. In the same way I was analyzing how open source was done when I was doing research in academia, now I'm analyzing with all the repositories that were already available in the company, hundreds of repositories, years of history, thousands of lines of code. So analyzing how they were making software and just showing the data. So this is our motto: in data we trust. Okay, so what we're doing actually is using some tools from Vitergia. So and I want the sticker now. And so we are using some of the tools of Vitergia. Some of my code is still on those tools, and you know it. And and analyzing how people are doing stuff. So these are just some examples. So we have discovered issues in the way we were doing software, and people realized like, oh shit, I didn't realize I was doing this. I don't know, I didn't realize I was committing Python binary files to the repo. Oh, I will not do that anymore. So the basic things, but little by little, all these guidelines about how to do stuff I'm not marking that. I'm not telling people what are the guidelines. So people are finding the guidelines by using data and agreeing on, oh yes, this is an issue and we should do it all together. Okay. So this is actually a new dashboard that is not available in Grimoire Lab, and yeah, maybe we should open source it. It's using some size metrics from the output of Perceval, the repository analysis tools. So we find things like these things, okay? So I will not mention that. We're recording this, right? Okay. So we should put like beep here, okay? So like for instance, well, we have huge files in the repository that shouldn't be there. We have discussions about what is the most used programming language in this bank in all the history. And people were thinking, wow, probably Python, because that's what people love. And now we're trying to shift some projects to Scala, and that takes time from people to learn a new language, a new programming paradigm, and so on. And actually, for instance, Scala is one of these languages. It was like the second or the third most used language in the company, and people were surprised to learn that. So they were not even aware of those basic things. Okay, well, so this is all. If you are interested in knowing more about the projects that we are doing, many of the projects that we do, we open source them. The ones about the data science, or more specific about data science, are in this GitHub account. And the ones more about infrastructure, mobile, front-end, and so on are in this other account, in the BBVA Labs. So you are invited to go there and fork the repositories and contribute. So most of them, if not all, are under the Apache license. It's quite permissive, so you can practically do whatever you want with these projects. Okay, so this is all just if you just wake up after the talk and you want to know what I said, or you're gonna go back home now and you're gonna tell your mother, your wife, whoever, what was the talk about. So these are the things that you have to tell them, okay? So data scientists are not developers, but they are writing software every day at every moment. We deliver software, very specific kind of software, but software nevertheless. Because we are writing software, having continuous integration and a process, it's a must-have, and you cannot ignore this. And having a process is not just having a Git repository with code where people put things together. It's much more than that. It's having a process that, with a goal of producing zero post-release defects, okay? And we have seen that this is important not only because of quality, but also because of credibility. Data science are very specific profiles in an alien world in companies. It's the kind of profiles that companies were not hiring 5 years ago, and that companies rejected 5 years ago because they were complicated people, outsiders, and all that. Okay, and they are now realizing the value of these outsiders in the company, but the companies are just groups of people with a shared interest, a shared culture, and the data scientist culture is a little bit different. So credibility, maintaining your credibility, improving your credibility, getting the buy-in from the other parts of the company, it's very important. So having a continuous integration process with the goal of zero possible defects, it's essential for the survival and the growth of data scientists in companies. And also having a culture of sharing. Okay, so you cannot work in an isolated way. You have to avoid work that others have done before. You have to avoid reinventing the wheel. Okay. But at the same time, you have to keep end-to-end ownership. So you will not have innovation, you will not have innovative products if you don't let people to work in an autonomous way. And the consequence of all this is that the data that all this process produces allows you to make a continuous improvement and doing things better and learning about how you are doing stuff. That when you are working, you are not aware about how you do stuff, and when you show the data, people working on the same stuff for years, they are surprised by finding out stuff about themselves with data. Okay, so this is all. So thanks for your attention, and do you have questions now?
I have a question.
Yes.
It's a little bit off topic, but so I see that you are open sourcing things.
Yes.
How hard, how difficult was that? To open sourcing the bank?
Well, I haven't been so long in the bank, so I've been involved only in the open sourcing of one project, and it was actually, and I have to say, surprisingly to me, quite easy. So there are clear guidelines of what you have to do for the process of open sourcing something, which is basically auditing the code, and I was involved in auditing the code of someone else. It wasn't my project, and then you have to go through the legal department to make sure that the license and the copyright notices and some other stuff are all right, and that's it. So you don't have to do a lot more. So if you go, for instance, to the first link, if you go to the first link, the one about the generic about BBVA, you will see there are tens, maybe hundreds of projects there.
But is it more like a publishing of a finished product, or are you continuously building the product in the open?
Both. Some things are more done and they are open sourced after they are delivered. Let's say the project that I was involved, for instance, so it has already a large code base, but it's been developed in the open, and the goal is to try to attract a community to also work in that project. But it's very young, so it has been in GitHub since since actually January, so it's a month and something, so not so long. But yeah, you have both cases. So go to the GitHub account, have a look at the project, and you will see it. You will find all kinds of stuff, projects that are evolving very quickly now in GitHub. Some projects that are not attracting so much activity and are kind of done and delivered, and that's it. You have all cases.
Thanks.
I have more little curiosity on the detail of the 7 on the list of the 7.
Yes.
If I understand well, was one code reviewer. If it's a code,
no.
No.
One
Okay.
code review at least.
Okay.
Then,
Okay.
so that's the minimum required. Okay, so then you maintain the ownership of your project. So you may decide to make more reviews if you want. So.
Okay, no, yeah, I read. I will not read well because I was thinking in this case how it's possible to choose one person for a thing. I don't know. I am.
Yeah, so some things actually they are doing 2 code reviews at least. You need 2 approvals in order for your pull request to be merged.
No, because I used it to put all the team on the code review, so we are.
So the code review is open to anyone actually. So even you can go and review the pull request of a project that you are not working,
Yes,
you are not involved. So more as a suggestion, or if you are expert in a technology, so you are actually encouraged to go to a specific project and provide guidance and advice on how people are writing code. You can do that perfectly. So no, but in order to be able to get the seal of approval from the software engineering team, so you need to do at least 1 code review. But more than that or something that different than that, it's up to the project to decide how to do it.
Thank you.
You're welcome.
Here.
Yeah.
I have a quick question for the data scientist. How big is the community in data scientists in Madrid? Because I think it's a kind of a new thing, data scientists.
Not in BBVA. So the company, Data Analytics, was born in 2014, I think. And there were already data scientists inside the bank earlier than that. And there are data scientists in the bank in many different departments. And I don't know, I cannot quantify how many exactly, but so more than 100 for sure, because it's around 100 people in data analytics, and probably it can be 200 or more. And then there are data scientists also in other locations, in Mexico and many other locations of the bank, and it's a growing community. So if you want to work for a data scientist, as a data scientist for BBVA, there are lots of open opportunities. So.
Hi. You mentioned before that you have been following this new approach, this new pipeline for delivering software.
Yes.
Is this something new you have adopted
Yeah,
recently, or this is something that it was already in the past?
No, it started when I joined, so it has been running for 6 months, and it's still ongoing. So it's not fully developed. So some projects are working entirely with this process, and projects are starting to be shifted to this process. So there are projects at different stages in the maturity of following the full process.
Okay.
But it started 6 months ago.
Okay, thank you.
You're welcome.